Hi everyone, welcome back to my channel. Today we will be doing this particular question, longest consecutive sequence. So in this question we are given an unsorted array nums and we need to return the length of the longest consecutive element sequence. So we are already given that we should write an algorithm that runs in order n time. Although we will look at naive solution also. So if we look at this input nums, we know that the longest sequence that can be formed is from elements 1, 2, 3 and 4, and this length is 4. So the output says 4. If we look at this particular input nums, in this case if we try to find out, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and this is the longest sequence from 0 to 8. So the output says 9. Now let's understand the question and try to build a approach for this question.
Okay, so the question says we need to find longest consecutive sequence and the given array is unsorted already. So from this array, if we choose 100, do we have 101? Do we have 101? No, it's not. So currently the longest length is equals to 1. If we choose 4, if we have 4, do we have 5? No, we don't have. So this remains 1. If we choose 200, do we have further sequences of this? No. So we are not choosing these. If we choose 1, do we have 2? Yes, we have 2. Do we have 3? Yes, we have 3. Do we have 4? Yes, we have 4. So the length becomes is equals to 4, and this is the longest length possible for this array. So this way we need to find what can be the possible length that can be formed. So what's the most naive solution that you can think of? If we have an element, let's say n, next element that we were looking for is n plus 1, which is after 100 we were looking 101. So next element that we are looking is n plus 1, then n plus 2, and if these exist we are increasing the length. So considering this in mind, we can form our brute force. So the brute force says for every number, so the brute force says that for every number, try to build the sequence. Keep checking for n plus 1, n plus 2 and n plus 3 and update the max length for that. So for brute force, for scanning every element, we will have an outer loop. So we will have the ith element as current element, and initially the length is 1. Why 1? Because initially we are choosing one element, so 1 is a length in itself. Now we will check if this current plus 1 exists somewhere in the array or not. For that, let's create a function for linear search in this array, which element current plus 1 element. So let's call the function exist, which will take basically a vector, and in this vector it will check if the number exists or not. So what this will do is, this will check if num is equal to target. If yes, it will return true, otherwise return false. We will use this function here. So we will check while exist in num's array, what exists, current plus 1. If it exists, that means we have the next element in the sequence, so we will increment the current, because current is now 1 plus with the older current, because current is now incremented. Previously it was, let's say, n, and now it will be n plus 1. Now all we need to also increase the length, because we have found one more element in the sequence. So this way, after completion of this loop, we will keep longest in a variable, and longest is maximum of whatever was the previous longest, and the length from these, whatever is the maximum, comes into the longest, and at last we will return longest. So the longest is a integer variable. Let's give it initial value as 0. At last we will return longest. So this way, this is a brute force solution. We have this loop and an inner loop at exist. So the time complexity becomes order of n cube, and the space complexity is order of 1 because we are not using any extra spaces. Why this is bad? Because we can see this is order of n cube. We are repeatedly scanning, recounting same sequence multiple times. Extremely slow for large inputs. So we optimize this using sorting first. Now, is there any better approach? We know that if we had array sorted, then we can just find elements adjacent to each other. If let's say this was sorted like this and we started scanning this array, then what we would have done is, when we picked starting point as this, we will find all adjacent to each other, and if we pick starting point as this, we will find adjacent element. We can instantly decide that we have the longest sequence in future or not. So the main thing that sorting helps with is that consecutive number will appear next to each other. We just need to count streaks. So let's look at the solution also for this. So for this, what we'll do is we will sort the array. Then what we'll do is we will count the current streak and we will keep it 1 because initially we will take the first element. Now we will keep the longest variable also equals to 1. Now we will traverse from index 1 and we will check if. So we are starting for index 1. We will check at first index. Is this equal to whatever was on the previous index plus 1? If it is, that means this will increase the streak. And if both are equal, these two numbers, in that case, this means it is a duplicate. So we need to ignore this. If these are not equal, in that case, we need to reset the streak. Because let's say we are on 100 and we checked 200 with this. So I is here and we checked this plus 1. So this does not qualifies. So we need to reset the streak by ignoring this and move further. At last, we need to update the longest. Now let's code our solution. So what we will do is, if the array is empty, we will simply return 0. So first let's check if the num's array is empty, we will return. So the first step is to sort. So we will sort the array. Now after sorting, we need some variables. Let's initialize them. So we have the longest variable and current streak variable is equals to 1. Now we will loop the array. Now what we will check is if, so we are starting I with 1. So we will check the ith index element is equals to the previous index element plus 1. If this is the case, then we have the element in the sequence. So in this case, we will do current streak plus plus. Else, we need to handle duplicate elements also. So now what we need to check is if this element is equals to the previous index element. In this case, we need to skip. So what we will do is continue. So this way the loop will continue and ignore this. Else what we need to do is, if this is not the case, this is not the case, in that case, we will update our longest because whatever the streak was, it has broken. Now the streak will start again. So after this for loop, we need to reset our longest to max of longest or current streak and we will return longest. So this is a better solution than the previous one. The sorting takes n log n time and we have a single traversal which is this. So this takes order of n time. So the final time complexity is, which one is bigger? N log n. So we have order of n log n. And in terms of space, we have not utilized any extra spaces. But after this, the problem clearly says that we need a order n solution. So sorting already cost us n log n. So we need to think something more smarter. So this is where HashSet comes into picture. So the main idea is that we will use HashSet what we will do is we will put everything into the hash set. Only start counting when the number is the beginning of the sequence. How do we detect that it is the beginning of the sequence? A number is a start only if n minus 1 does not exist. So let's say we have a sequence. So if we want to check if this is the start for a sequence or not, in this case the number is 100. Just decrement it by 1, 99. Is 99 present in this set? No, it's not present. So 100 is a starting point for a sequence. Let's pick 200. Is 199 option in this particular array? No, it's not. So 200 is also a starting point. Let's pick 1. So we have 1. If we do this 1 minus 1, we have 0. Do we have 0 in the set? No, we don't have. That means 1 is the starting point. Let's pick 2. If we pick 2 and we do 2 minus 1, do we have 1 in the set? Yes, 1 is there. So 2 can never be a starting point for a subsequence. So this is the main idea that we will be using. So the algorithm says that we will insert all numbers in unordered set. After this, we will initialize longest as 0. Now for each number which is in the set, what we will check is if num minus 1 not present. If this is not present, we will start counting and we will at last update max length. So this is the idea that we will using. We will insert all numbers into the hash set. We will initialize longest as 0 and for each number we will check if num minus 1 is not present. If it is not present, we will start counting and we will update the max length also. So if we code this, what we will have is we will have an unordered set for storing integers. And let's say the set is st and we will initialize the set with all the elements of nums array. So we will add nums dot begin to end in this particular unordered set. Now we will have longest as 0 initially. Now we will loop through the array. So for a number in set, what we will check is if set dot count of num minus 1. We will check the count of num minus 1 in this particular set. If it is 0, so that means this is the beginning of the sequence. So what we will do is int current is equals to num, and now we will have the length as 1. Now what we will do is while st.count current plus 1. So until the next sequence of current exists, we will increment the current and increase the length. So this way we are counting the actual sequence and we will have longest and longest variable, and longest is max of longest and length, and at last we will return longest. So this is the overall solution that we have using HashSet. So the space complexity that we are using is order n because we are using sets here that takes up extra space. So if we look the time complexity of this particular solution, it's order n. Every element is processed at most twice, once in the loop and once in the sequence counting. Therefore, total work here is linear and space complexity is order n because we are using sets here. So this is the solution. I hope you understood it. We will code it on LeetCode now. I have coded it on LeetCode. We have an unordered set and the set is st. We have initialized it with the elements of the array that we have from begin to end. We have a variable longest is equals to 0 and we start iterating through the set elements. We know that we only need to start counting if it's beginning of the sequence. So when it will be the beginning of sequence? When the num minus 1 does not exist in the set. So we will check the count of num minus 1 into the set. If it is 0, in that case we know it is the starting of the sequence and we can check for more elements of the sequence.
So what we did is we have current element is equals to num and we have length is equals to 1. Now what we'll check is while the count of current plus 1 exists, we will increase the current and length. This way we will have the longest in length, and we are here updating the longest variable, which is max of longest or length. At last we are returning the longest. I have run the test cases and these are passing. Let's submit this code. So this is perfectly fine solution. For more such videos, please subscribe to my channel. I will bring in more patterns like this. Thank you so much.